Okay, so what we want to do is find that area of the surface. Okay, so just a surface generated by revolving this guy right here from 2 to 8 around the y-axis. Okay, so we'll get an area here. Now how are we going to do this? Well, first, before we start anything, we really need to figure out what this guy looks like. So let's go ahead and graph him. So if I pull up Desmos and I plug him in, you'll notice that I have a half of a circle. Okay, right over here. And this is a circle that has a radius value of 9. Okay, and its center is 0, left, and right, up 9. Okay, so that's what we've got. So we're going to rotate this guy around. So what we need to do is figure out the surface area. So let's go ahead and set up our equations here. So what I've got, I'm just going to draw this guy out here again. Okay, so our graph looks something like that. Now what I need to do is rotate around. So what I'm going to do, and actually let me go ahead and do this. Yeah, let's just grab this graph. Why not actually just use the actual graph? There it is. Now we can play around with that. Okay, so what we're going to do is we need to rotate this guy around the axis, and we only need to go from 2 till 8. So let's go ahead and mark those guys out in here. So here is, let me do it in red. Actually, I'll do it in black. So here's 2. Okay, so from here to a height of 8. 8 is right here. Okay, so this section right here is what is getting, that's what's getting revolved around. We need to find that surface area. So what we need to do is use the formula, and we're essentially using the arc length there, right, and then multiplying around. So what I'm going to do is go ahead and grab the formula. Okay, so we've got this formula for the surface area. Okay, and what it's done is we've used that formula for the first system of the cone, okay, and also part of our arc length, okay, here. And so this is going to give us the surface area by revolving around. Okay, now notice that I changed it to y because y is our variable. Okay, we're rotating around the y-axis. Okay. So now what I'm going to go ahead and do is compute this. So what I need here is I do need f prime at y. So let's go ahead and calculate that as a side note. So f prime of y, okay, that is dx dy. That's what I need. Okay, so I have x is equal to the square root of 18y minus y squared. So I need to take the derivative of this guy. So with respect to y, so dx dy is going to be equal to, okay, when we take the derivative of the square root, we get 1 over 2 times the square root of that guy, multiplied by the derivative of the inside. And the derivative of the inside is 18 minus 2y. So I can go ahead and factor out a 2 here. And so I'll have 9 minus y over the square root of 18y minus y squared. That is, dx dy. That's how x changes with respect to the y variable. So what I'm going to do with this guy is I need to square it. So dx dy squared is going to be equal to 9 minus y squared over, now I'm going to square this guy, that's going to be 18y minus y squared, like that. Okay. So that is going to go right in here, but I'm going to have to add 1 to it and take the square root. So I might as well just go ahead and do that here. So let me get a little bit more room. So I need to go ahead and add 1 to it. So we have 1 plus, and now if we want to, we could do this guy out, but I'm going to wait for just a second before I work with anything there. So this is going to be 18y minus y squared plus 9 minus y quantity squared all over 18y minus y squared. The question is, do we go ahead and simplify this? And I think at this point, yeah, we'll give it a shot. Okay, it'll probably make life easier. So we have 18y minus y squared plus 81, okay, minus 18y plus y squared over 18y minus y squared. So let's see what that gives us. We've got this 18y and this 18y cancel out. This y squared and this y squared cancel out. And so what I'm left with here is just 81 for the numerator, and then 18y minus y squared for the denominator. And if I want to, I can factor out a y. So I've got 81 over y times 18 minus y. So this right here is, looks like it's this chunk. So S is equal, surface area is equal to the integral of 2 to 8. We pull the 2 pi out. Okay, f of y, well, the function y is going to be equal to, I've got the square root of 18y minus y squared multiplied by the square root of this guy right here. You know what, I'm going to go ahead and leave it as 81 over 18y minus y squared, and then of course this is dy at the end. Now if I take the square root of this, what I'm going to get here is the following. Oops. Square root of 81 is 9, and the square root of this, I'm just going to leave it, because notice that these guys are going to be the same. Now, these guys are going to cancel out, and so we have 2 pi times the integral from 2 to 8 of just the value 9 dy, and of course the integral of this is 9y evaluated between 2 and 8, and of course we still have to times that by 2 pi, and that's our surface area. So our surface area should be equal to 2 pi times the quantity. 9 times 8 is 72, minus 9 times 2 is 18, which should be 9 times 6, which is 64. 63, excuse me, 60. Wait, hang on. What did I just say? 54. Okay, so, because really, look guys, this right here, the trick is, I mean, you can just do the math out, but look, you've got 9 times 8 minus 9 times 2. Well, I could just pull the 9 out if I wanted to. Okay, times 9 like that, and then this just becomes 8 minus 2, which is 6, right? So this is 9 times 2 times 6 times pi, which is 12 times 9, which is, let's see here, 12 times 9, 10 times 9 is 90, plus 18, so 108, it looks like, so 108 pi. So let's go ahead and check to see if that is our answer. And there we go. Okay. So to answer the question that was posed, do you have to use substitution here? I don't think I use substitution at all. um, throughout this problem. Now you might look at my work and say, hey, wait, you could have done this or this, quicker and simplify stuff, and maybe that's true. Okay, but again, I'm just working these problems out, right? And just like you would do, just like if you were working stuff out, you get to some spots here, guys, and you look at stuff and you say, oh, maybe I'll factor, and then you go back and say, no, wait a minute, let's not factor, let's just leave it the way it is. Okay, so play around with those problems.